So let's generate an app that can take any point cloud like this and generate a GIF or an MP4 like this one or this one or this one. And what we want is take any like raw point cloud and develop this full system that can handle that, right? So in here, normally it executes the program and then after it will generate the GIF and the MP4. So this is the coding adventure that we're going to start on right now. So let me close everything and show you how we can do that. What we want to do is very simple. We'll generate this, I will try auto draw. This will be our bread. And essentially we start with a 3D data set. And what we want to have is a GIF and an MP4. So let's generate a GIF and after that an MP4. And the process will be very simple. The 3D dataset will go there. We'll do the magic here, magic. Okay, and we'll push out a GIF and an MP4. So this is the high level view of things, right? And now that you have that in mind, maybe we can dive into the deeper view that will have several steps, which I have already in here. So loading the mesh would be the first thing. We'll want to make sure that we can visualize a 3D mesh with a backend. Then we'll move on to visualizing a point cloud because we want to handle point cloud, and then experimenting, generating our GIF and so on. So let's dive right in. The first thing is that you see I only leverage two libraries, so NumPy and PyVista. If you already know me, I really like to have a minimal number of library. This is much more sustainable. So loading the mesh with Open3D. So let me set that, execute that to load our library, and we will test it with a very cool little data set. You see with PyVista, you can get already data from an example module, and this is the globe of the planet Earth with the texture. So if I were to do this normally, so let me check here. Yes, you have the Earth that is plotted directly. The resolution is linked with the texture, but this is very nice. So this is also something, if you want to play around with visualizing the Earth, this is one way to do it. So how do we achieve that with PyVista? It's very simple. We load in the variable mesh, we load in the variable texture or texture, and then after we create a plotter. So this is the canvas on which we draw our scene. And what we add on our canvas is the mesh with its texture and some kind of parameters. And whenever we are finished, we just show our canvas. And this is the only thing that we are going to leverage. But in the end, we will want to generate the GIFs and the MP4. Very good. So this is the first stage, loading the mesh. Everything seems to be working. Just one little PyVista, a quick maybe help. In here you have a lot of example, an overview of how you can use it. It's a very cool little piece of library. If you did not know it already, I encourage you to go through all the examples. Super cool stuff if you're playing with 3D datasets. All right, back to our project. So the first stage is done, wonderful. Now let's dive onto the second stage, loading and visualizing our 3D point cloud. So as you can see, I have a point cloud. So if I were to go in this specific tutorial, I take the opportunity to say that you can just download the resources down below, like always. And you see that I have my data set, which is here, street sample. So this is a PLY, a little point cloud to test out things. We will load it with pv.read, and then we will just create some kind of Scala field called Scala that will essentially take let's say the height or the extent around the center, and this will be very useful for visualization. It will create a nice effect. So it will be a specific value at the center and the most extreme value at the opposite from the center of your point cloud, right? And then I just use the plotter. I add the point cloud and I show. Let's try if this works. Yeah, it works. The only thing is we did not use the Scala so far, which is fine. We'll do that in the next stage. But we can load our point cloud That looks pretty fine. We just have no color, no nothing on it, which is normal. Let's move on to step 3, experimenting and adjusting the parameters. So I already pre-filled everything, but essentially let me walk you quickly through what is happening under the hood. So in here, this is just a parameter to say that we don't want to render off screen, but we want to use the actual screen. And this is if we need to scale, but this is a parameter that we'll use for off screen later on. So let me delete that. And as you can see, we add the point cloud and we use a style point. Okay. And we also use the scalars for the colors. And that's pretty much it, that the base color that we use on top of it, the opacity, the size, and we add a little text, we add a little background, and we enable a way to simulate lightning because I think it's nicer. So if I were to execute this, you see that the scene is already massively uphold or the experience enhance, and we could play now on various parameters to better understand. So for example, in here, if I would like to essentially like increase the size of our points, well, this is very easy. I could put in here 10, relaunch, and you see that we have bigger point cloud. Just to show you the influence on the IDOM lightning. If I comment that and I relaunch, you see that you don't have the simulation of the lightning. You still have things as sphere. So now if I were to render point not as sphere, this is what we will get. Okay. So as I mentioned, the most extreme value outside, and in the middle you have the 0 value normally. If I take scalars, let me close that and explore scalars. Yep, in here, scalars, yeah. So NP max the scalars 36, and the minimum value is 0.43. All right. Now, on the emissive aspect, this is only if you use another style and not points, but something else. So this is something, if you use Gaussian splatting, this is something just to show you how hyped it is for actually some kind of rendering strategy that we have been using for a lot of time. So if I were to render that, you see that instead of having a point, we have splats or Gaussians at each point position, right? So this is super cool. Now, if I were to like bring down a bit the opacity to, let's say, 35 and print that again, we'll have something a bit nicer as well. And what we can do now is maybe play on the emissive and put that on true, see what we get from that. Nothing, because I think we should render that as spheres. Yeah, and you see what you get. A very nice way to render point cloud, and this is something where you can really play onto like cyberpunk cities or things like this. It's a nice way to render your point cloud. So you can bring down the opacity to have something a bit nicer maybe to look at, right? Yeah, and this is what you will get. I really love this kind of rendering. Now, if I were to put that to false and increase a bit the opacity, this is what we would have at this moment, but it's not using the Gaussian splatting. So let's move back to what we had initially to see if that's something that is nice or not. Yeah, I like this kind of rendering. And when we rotate, the problem is with the opacity, we have a bit of a wrong impression. So we could put that to 1 to avoid this kind of impression and have our point cloud handled like this. So this is one way you could visualize the point cloud. I really like it. Of course, you see that I have a little test here. It's not necessary. But what I think is cool is if we enable the IDOM lightning on top, this makes things pop up really nicely. So this is the parameter that I would like to save. And this is the end of my experiment. We can now move on to actually generating our GIF. So for that, maybe I can just draw something here. Essentially, we have a point cloud like this on the top view, right? So this is our bounding box of the point cloud. And what we would like to do is generate a little orbiting path on which we sample in any number of cameras, okay, and every time we will render a frame from this point of view, every time we want to shoot at the point cloud center, okay, which means that if we were to put the orbit by using parameter constrained by the point cloud, we will be at the same level. So maybe something that would be good, right? So this is an X, Y view. Now I will move that. And if I want to draw maybe X and Z view, okay. Here what would be interesting is if our point cloud bounding box is now like this, if we were to use the center of the point cloud, then we would have all the orbiting at this level and the view generating like this, which would be a bit annoying. So what we would like to have is actually to move the center point here and this adjusted based on the center of the point cloud. To do that, what I propose is to use the diagonal of the bounding box and to use that to basically push up our view up. This way we will always have the full bounding box in the frame of reference and it will handle any case, any complicated cases. So this is a very super nice trick that we are going to do here. Okay, so now back to our experiments and our Python script. Let's open up generating our orbital GIF. So what I did here is essentially, if I take back all of my parameters here, the things that I will change is taking the off-screen to true and the image scale to 1. I will show you what the image scale does right after. So I just changed my parameter to what we set up together. Now I like to have the background black, enable hide on lightning, this is good. And the only thing that we will want to do is to cancel this auto close because we'll actually use it not interactively, but through the creation of the GIF. So if I zoom onto this little line here, what is interesting is that we create our path that I explained just before in here. This path is created exactly in here. We generate an orbital path with 40 points sampled on this path, and we shift it by using the cloud length parameter. And the cloud length parameter, this is the value. It's 90 meters for this point cloud. This is exactly the extent of the diagonal of the bounding box, what I mentioned. The view up is just a vector that I created here. It permits to shift slightly the plane defined for your orbital plane, essentially. So you have the path defined, but then you put the path on the plane, which means that if you want this plane to be perfectly horizontal, you just put a normal of 0, 0, 1. And if you want to tilt it a bit, right, which I did in here, you can change some values. Essentially, if you want something really nice, I really encourage you to just use the normal vector, but here it's just to show you the impact of what it has. So if I am launching this, it will take some time, but normally not too long. And if I go in my folder, you see that I have a file called orbit.gif. Now it's finished. So if I were to double click in here, we see that we have our orbiting point cloud that is created, and it's a GIF. So already at this stage, you have a very quick way to take any of your data set, generate a GIF, and use that for your communication, for a report, to populate a presentation. So this is a super nice little handy trick. Great. Let's not stop here and continue. If you want to generate an MP4, essentially, you just take all that we have before, right? And what you will only change is, instead of using open GIF, you will use open movie. And the same thing happens after you orbit on the path. So it means you use the path to orbit around and you write the frames and you use the view up that we mentioned before. So this is the same thing. And I will call that orbit cloud. So if I execute this, you normally, if I refresh, yeah, orbit cloud is now here. Oh yeah, that's where I changed the parameters, as you can see, with the Gaussians. So this is super cool. Why it's interesting to generate MP4? In some cases, you are a bit concerned about, for example, the size of your GIF. So if I opening it a bit more, you see that my GIF here is 3 kilobyte more or less, and here it's 400 kilobytes, so 3,400. So it's a lot bigger, this one. This is why maybe if you have a way to generate MP4, this is also nice. Which makes me think that here you have an image scale. This is really to touch if you want to upscale your GIF and have a better resolution. You can put 2, 3, 4, 5, but that will increase by 2, 3, 4, 5 the size of your image. In here, we have an image that is full HD. If I were to put 2 times that, let me put it in here, Orbit Cloud 2, I will call that, and generate it. You will see that it will take also almost 2 times the same time that it took before to generate your orbital GIF. So I will just wait for it to finish, and now I have my second GIF, which is much bigger, and when I look at the size, it's 2 times the size, right? So this is really if you want to have something with a very high resolution, because right after you can maybe crop it and use only the usable portion in here. All right, this is good, this is done. Generating an orbital MP4, this is done. Now, what I propose is essentially, we will just create a function so that we can test that with multiple datasets. If I were to take here my drawing capacities, so I will put that in here for now. Why do I want to do that? It's because whenever I will create my app, right, this will be the app, the magic app, and we'll have our PLY point cloud for now, but you saw that you can do the same with a mesh or things like this. It will go there, and the app essentially should execute a Python script. Okay, and the Python script will get some kind of input from the user, which is essentially the path. It should store the data, like data management, and then it will execute that and spit out in the specific folder the result that we mentioned, which is the GIF and the MP4. Which means that here it will be best that we think with a functional approach. If I get back to my script, this is what I did here. I created a function. So essentially, it's called cloud-gify, and I will take an input path, and I will spit out nothing, but I will just, within my function, generate both my GIF and my movie. So I just took everything that we had before, and that's it. I just put that as a function to use the cloud and the Scala that we loaded before. Now we can test that with a lot of data sets, and this is what we have here. So what I did is I went in my folder and I just took several data sets which are here. I listed them in a list in Python, and then I loop over it, and for each point cloud path in the datasets path, I apply my cloud-g file that will generate the 2 files. And this is what you have here. Every time you have the orbit, very nice, and you have the MP4, very cool. And in here, so this one, that was the only one that was a bit tricky, but you have, okay, this is the MP4, this is the GIF, this is the point cloud, and this is another point cloud. So it worked beautifully. Now, to make that an app, you have several ways to do that. The easiest way is maybe to use Grad.io. You have another video where I use Marching Cube with Grad.io to showcase the result. But if you want to go beyond that and create something like this, this is the course 3D segmenter, for example, where I showcase how to do that, to automatically segment and use AI with this kind of GUI. So essentially, just to show you how it works, I have a server, so I will quit my server. It's a Flask server, so I just go in the path where my GIF app is. So this is how it looks like, and I will delete maybe anything that is my upload folder and anything that is in my download folder. And essentially, what I want to do is drag and drop a point cloud here. It will go into the upload folder automatically, and then whenever the process is ready, it will push the final result in the download folder. So first I need to launch my Flask app. So for that I do Flask run. Because my app is already very standard with app.py, I don't need to do anything else. And you see that I have my development server running in here. So whenever I open my development server, it's now working. And what I can do is take a point cloud. As you can see, I have nothing on upload, right? So if I take my street sample, what I asked my program to do is to first open the point cloud with PyVista and with the high DOM Lightning to just visualize, make sure things are working properly, which is the case. And whenever I close, it goes onto the second stage, which makes actually the GIF and the MP4. I'm not sure, I just generate the GIF for now, but you can just add the MP4 after. And when the process is complete, you have it in download result folder. So now if I go there, yeah, I have my GIF. Right, so let's test it with another data set, which is this one, industrial room. If I do that, we can visualize our point cloud. Very nice. And does it work? For the second stage, this is pure test live. I didn't test it with this one. Hopefully, let's cross the finger it works. Else, it means that I need to work a bit on the approach. But it looks like it works. Before saying anything, let's look at the results. Yeah, it worked beautifully. So you have it, guys, a way to generate an orbit path and use that to generate GIF only with Python, which means that the next stage is to essentially build the app you saw with your own skill or with the Segmentor OS course and generate a lot of GIF whenever you want to communicate with any of your 3D datasets. I hope this help you and see you in the next video. Bye bye.